All right, so this should be recording. Let's hope this works. I'm going to be showing you guys how to go from a kind of topographic map with some strikes and dips. We'll put that in to drawing a cross section, right? This is kind of putting pieces together. I do suggest that you guys watch those videos online that we've linked. Go find more videos. There's some really, really excellent videos out there on how to put together geologic cross section. Um, in many cases, they're going to go into more depth and kind of talk about the structure behind things and how you'll be expected to do things in structure. This is field observations. We want you guys to get down the basics, not necessarily be absolutely perfect. But the whole idea is taking what you see in the field and we're able to mark onto your topographic map, and then put it into a cross section that kind of shows us what you think is going to be kind of below the surface. What's the geometry um, in the area that you were mapping? Okay, so this is our topographic map. This is where we will be putting a cross section. I'm just sketching this, so I don't really have a full plan of exactly what's going to go into this, but this should give you the basics of what we'll be looking for. All right, so if we start with our topographic map, I'll draw on the layer and we'll see how this goes. So we start with our topographic map. I have a cross section through here. I have an X, I have an X prime. When I eventually go over to my cross section, I'll have an X on this side and an X prime on that side. So if I'm in here and kind of like moving from, say we walked from this side to that side and we took some strikes and dips. And let's say that we took a strike and dip in a unit over here and it was kind of striking like this and it was dipping in that direction, right? And we'll say it was dipping like 50 degrees, okay? And then we went and we kind of walked around all this way. We got to area and we got to this thing and it's dipping like 60 degrees. It's also dipping to the north, so that's nice and convenient. And then we get over here and it's dipping, let's say it's dipping, that's dipping to the south. Kind of odd. Okay, that's fine. And it's dipping maybe like, let's do like 45 degrees. Okay. So we'll make this, let's see, let's put in one more, kind of to match what you guys did with the Newport one. Let's put in, we walked all the way through the mountain and we've got one that's dipping kind of like that. It's almost just about perpendicular, so nice and easy. And we'll make this another dipping 60 degrees to the north. We're not going to worry too much about strike. The reason why we're not going to worry too much about strike is because this is a very convenient map. The other two projects that you have in this class are very convenient maps, very conveniently placed cross-section lines. Because our cross-section line is essentially perpendicular to where our strikes are, we can assume that the dips that we are getting are going to be relatively close to the true dip in that area. Now, when you're in structure, that's going to be something you're going to have to actually think about. Is that actually a true statement or not? We've done an activity to kind of talk about how that's not technically a true thing, but we're going to take that as true. So our dips here, we're going to take as our true dips. And I'll show you guys how we're going to kind of do that. Okay, so I've got now these strike and dip symbols, right? So I've got these three dipping to the north. I've got this one dipping to the south. Okay, so let's see, north, east, south, west-ish, right? So let's see if I change my color. Okay, so we'll have kind of this pinkish one is going to be this one. Okay, That's nice. That's fun. Okay. And we'll have kind of a bluish one will be this one. That looks much more purple than blue. There we go. All right. And then we'll have this one can be kind of this green color. Okay. And that one will also be that green color. Okay. So we've got 3 units. We've got the pinkish, we got a blue purple, we have 2 greens. Okay. So say when we're walking, we realize that there is a kind of, and I'll put this in maybe a darker tone. We realize that there's like a contact here, right? So we realize that like right here-ish, we have a contact. If this were a thrust, we could say, okay, well, which way is it thrusting? Is it thrusting? And whichever way it's thrusting, you're going to put like, like the teeth in, that you might have. We're not going to worry about that for this one particularly. You did have to kind of put it in on the Newport map. Not a big deal here. Okay, so, and we're walking again, and we're like, okay, there's another like contact here. There's the green on this side, and then there's a purple on this side, and then this is the pink. Okay. So green's on this side, purple's on this side. And so we're like, okay, there's a contact. So that we know that one for sure. We know this one for sure. And I'm pretty sure it goes in kind of like that. Okay. Now if we have this strike and dip and this strike and dip, we know that they're the same unit. We see green all the way through here, right? So we know that all the way through this is green. All the way through this is the purple. All the way through this is the pink, right? So if we know that this green unit is all one thing and stepping this way on this side and that way on that side, we can assume that it's this kind of anticline shape, right? I have past it. We can assume that's this anticline shape where we have a dip kind of to that direction and we have a dip to that direction. So you get the upside down U, right? So we know that somewhere in here is going to be that anticline. Now, we can't necessarily be sure that this area, if we were to, is exactly going to connect. So like this line, if this were like a bed, would be exactly the same as this 45 degrees. So there's going to have to be a little bit of assuming that goes on since we don't know where this green unit ends and where another bed begins. So how do we get all of this, all of this craziness, right, onto a cross section? Put that there. Okay, so how do we get this stuff onto a cross section? So first thing that you want to do is you want to say, okay, neat, I've got all of this stuff. I've got strikes and dips, I have my different units, and I even have an idea of where these unit contacts are going to be. And I know where all of this stuff technically is kind of intersecting with my x to x prime, so my cross-section line. So first, what you do is you want to make sure that you've got this onto here, okay? So let's see. This was unplanned. I think we are going to do this part first. So we're going to skip over to the cross section first. Something that you need to make sure that you have for your cross section. Maybe I'll edit this video later. I'm not sure. Something that you need to make sure that you have ready for your cross section before you start putting anything onto the cross section is that you have the topography. Now for the Newport one, we gave you that. For the freeze location, we did not give you that. So what you're going to have to do is you are going to take your cross-section line, right? So what I suggest you do is you take like a piece of paper and you line the piece of paper up with the cross-section line itself, right? So like the edge would be along this. And then you can kind of wherever something intersects with the cross-section line. So I would do this first for just the topography, and then you can do that to deal with the strikes and dips, and then with like the contacts, we'll get to that in a little bit. So just for the topography, what you're going to do is you are going to take your little piece of paper, kind of line it up. So it's go X to X prime. And then every single time that something intersects with your X to X prime line, you're going to mark where the topography is. So to try and get this, let's see. Let's see if I can not completely distort the thing. Okay. Put another layer on here. All right, let's see if I can do this just about right. So at this point, there's an intersection. 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 There's an intersection, and then this is my X. So my X is my X prime. We also know that my X is to the northeast. So I'm going to I'll put it down here. Really, you should put it up in the corner, but I'm going to put northeast, and then that means that this side is southwest, right? So that gives me my orientations. Now I'm going to say that this blue line here is going to be, let's see, this will be 50 meters. This will be 100 meters, and then this will be 200 meters. So to make my life easier, I'm going to write 2, a 2. That doesn't make any sense. Hold on. Not 200 meters. Each of these lines is 50 meters, then that means that, no, and then this will be 100 as well. This will be 150. There we go. So it'll be 5, 100, 100, another 100, 150, 150, and 100. All right, take that away. Now I've already marked this. This is going to be 200 meters. This is 0 meters. You always want to mark where 0 is. So my 0 is going to be at sea level, right? 200 meters is above sea level. And then it's very good to have something that really extends to depth. A little bit more difficult when you're doing something like the Newport one, because we gave you a scale for that one. I just want you to extend it down to the best of your ability. But do make sure that you try to put in a scale. Of course, you don't know exactly what's underneath. We don't have any borehole data for the area that we gave you. Best guess, I'll take it, right? Do just about the same for freeze. And you're welcome to come ask about how deep your below the surface should be. So this is 200 below the surface, and this is 400 below the surface. Okay. All right, so let's see. This is 15. This is 15. Okay. This is 10. That's 10. That's 10. That's 10. Okay, and then 5 goes right there. And then I know that, let's see. It goes down between the two 10s. So I know that it goes kind of like that. I know it goes kind of up like that. Let's see, where did it end? It ended somewhere before 50 meters. Okay, so I'm going to say the intersection is there. All right. and then did that one, and then X prime is below 50 meters. Okay, so now I have my profile. Okay, see if I can neaten this up real quick. Make this a little bit. Helps if I hit the right button. All right. So, okay, let me write in my heights again, because that's something that you definitely need to have. So 0, which is sea level, okay, 200 meters, 200 meters, 400 meters. My handwriting is much worse since I'm writing on this pad. Okay, so now I have my topography. I have a above the height of the topography. I have the height below sea level. I like to put a little line in. You are welcome to make this like a little dash line. Maybe draw this in pencil or very, very faintly. It will be helpful. And then something that sometimes you'll see people do, and I think it's a good kind of thing to do, a good habit to have, especially since you're in the US, is to make one side in meters and then the other side is in feet, which I'm not going to do auto conversions for, but something you can do. I'm not going to take points off for it, but you might get half a bonus point. Anyways, so going back over here, now I have all this mess and I got to get this craziness onto here, right? So I need to get this pink unit, this purple unit, and this green unit with their strikes and dips that I took and the contacts onto that topographic profile. So once again, you're going to do kind of that, the idea that we took. Actually, I did that before. Once again, we're going to do the same idea where you took the piece of paper, you put it against the X to X prime line, and then you figure out where everything kind of intersects the X to X prime line. But one thing to kind of note is that because, very conveniently, because our strikes are just about perpendicular to our X to X prime line, what we can do is we can say everywhere, what is this? Okay, I am right. Sorry. Everywhere that I have a strike, I can say that if I were to extend my strike line out so that it crosses my cross-section line, then that would be where this, where you could kind of estimate that this measurement would be along the cross-section, okay? So I've got that. So I've got the places where it's going to intersect. I've got where in brown, that's where I'm assuming my unit contacts are. I know what unit contact there. I know unit contact there. Now I know where they should be. I also know that this bit needs to be an anticline and that this side is dipping that way and this side is dipping that way, right? So now I can take my piece of paper. For me, I'm going to take just copy the picture over. And we're going to do this. Give me 1 second. I'll get it loaded. Okay, cool. So now I can take this and let's see if I can do this again. Maybe, maybe not. There we go. Right, and it's going to be kind of the same idea. Now, remember that I want to know where my units make contact with the surface of the topography, because when you were seeing all these things, when you were taking these measurements, you were measuring them as they made contact with the surface of the topography, right? So first, to make sure that this is all oriented the right way. So I have X on this side, X prime on that side. My piece of paper, I might have it laying like this, and then I would make a little tick mark and a tick mark and a tick mark and a tick mark. And now what you do is you make yet another layer. There we go. I'll do this in orange so it's easier to see. So I can say, okay, I took a strike measurement right here. So we go up vertically, right? So that was taken about there. That was taken about there. This one was taken about here. And this one was taken about here. Now I'll do pink, and then this is purple, and this is green, and this is green. Okay. And we have a contact here. I'll do C. And then I have another contact here. And C. Okay. It'll be a whole lot easier when your paper is not blocking the topography, and literally use a ruler and just make sure that it's going vertical and it intersects the top of the topography. Okay. All right. So now I'm going to hide that. So this is really cool. Okay. So I need that piece. So first, let's talk about putting in the dips. Now, for the dips, as I said, you only need to put in like a dip, like a small tick mark, and make sure that that tip mark is dipping in the correct direction and measure the correct amount. Now, I don't have a little protractor loaded into my little drawing program right now, so we're going to just about assume. But do make sure that you are orienting your protractor correctly. Okay, so for example, if you have your line here, you know that this is your pretty much not a straight line. Okay, if this is your horizontal, right? When you have your protractor, you want to make sure that your protractor, like this might be 0 and this would be 180, right? So going that way would be 90, right? And then you're going to measure your dip. So if it's dipping for us to the north, north and east, and it's dipping like 45 degrees, then it would be like that, right? And you can make that dip mark kind of go in that direction, okay? Of course, if it's dipping to the opposite direction, of dipping to the south, and it's dipping 45 degrees to the south, then it would be dipping like that, okay? So making sure that you're orienting your protractor is very, very helpful when you're trying to put in angles. Remember, a slightly offset protractor is actually a huge degree difference in the angle that you're going to draw. Okay, so yeah, to do a teeny tiny eraser. Okay, so let's do, okay, so this is where my pink comes into contact with that. Then I will go ahead and draw this in pink. I realize that's a teeny tiny size. Sure. Okay, so this is my pink area. Make that kind of a lighter color. Okay, and that's dipping 50 degrees, right? Now let's see, if that's 180 and that's 45, then we'll do that. So let's say that's about 50, all right? So 50 from the horizontal. So 50. And then in my purple area, so in purple, my dip was 60, and that's 60 to the northeast. Okay, so let's see, that's one. I have my protractor, that would be 0, that would be 180, that would be 90, 90, 45, 60, so slightly more than the 50. And then let's see, my first green is 60. My second green is 45, but it's dipping the opposite direction. So my first green towards the kind of north-ish is 60, then 45 towards the south. Okay, so green. So let's see, my green makes contact here, and another green makes contact here. And this one is dipping, what, 60, right? So I'm saying 60 is there. And then this one is 45. So 0, 180. So this is where you would flip your protractor over. So 0, 180, and then 45 would be just kind of like that-ish. Okay. So as you see, these dip marks are not going all the way in because we're not saying that these are necessarily like the unit contacts. And we really want to illustrate the unit contacts for these particular cross sections. Okay, so I know where my unit contacts are. So the unit contact between the pink and the purple is right here, and then the unit contact between the purple and the green is right here. So what you do with the unit contacts is you kind of have to estimate the dip, unless you were right on it. If you're right on the contact, that's great, you've got it. If not, you kind of take the dip that's closest to the contact, and you can kind of assume. I think there's some arguments about if that's a good method to use. That's what you're going to do in this particular exercise. Close to the kind of measurement that you took to the contact, the more accurate that dip is actually going to be. We don't really have anything that's super close to this contact, so I'm going to go ahead and take about like 50, 60-ish. And then for this one, it's between two units that are dipping at 60 degrees, so I'll say that that's 60 as well. Okay, so let's mark that in, sure, brown. Okay, so this one, we have a contact here, and this is dipping 50, and that's 60. It really almost looks like the same angle, and that's fine. All right, so I'm going to take this, and I'm going to extend it first as a straight. You know what? I'm going to do this with a slightly lower opacity. I'm going to take this, and I'm going to extend it as a straight line. That did not, there we go. All right. And then this one, I'm going to do the same thing. I'm going to dip it all the way down as a straight line. Now, if you think that two lines are supposed to connect, I want you to extend them all the way down first before you try to connect anything, before you try to round anything. And the idea is that all the way down, you should maintain the unit thickness. Okay, so like what that means is that the unit thickness here should be about the same as the unit thickness there. You'll learn more why when you take structure. But for the most part, as units kind of dip into the surface, they're going to maintain most of that thickness. Kind of gets different depending on what kind of the history in the area. But for right now, try to maintain the unit thickness as you go. So like if something starts to pinch, maybe keep that. If you've got dips that kind of correspond to that idea, that's fine. But do try to maintain it for the most part. Anyways, so. Okay. So we've got those. And then we know that this over here, this thing is supposed to be an anticline. All right, so something that you could do is you could kind of go into the above the ground, and you could say, you know, kind of do dash lines, and then right in and to as an F. Okay, so that's nice and cool. Now, things to note. First, I have these kind of coming into contact here. I've got my contacts, sorry, these coming into contact with the topography. I've got my contacts which start at the topography. I go down, I have to extend it to depth. Now, do I actually know how far this extends? I don't know. I don't have any boreholes here, so maybe down here I might start to kind of dash the lines off. If maybe I know that, there's this gets folded over here, maybe I could start to say, okay, what folds? Neat. Those kind of dash lines or the I don't know kind of area. So that's fine. So like this is dashed, but this is already right away. This is dashed because I don't know what's really happening at depth. All right, so now I want to make this look nice, right? So it's a good idea to take this stuff away, right? Clean up your things. This kind of gets into, you want to make sure that your diagrams are clean and neat. If they're not clean and neat, if someone else can't read them, then your diagram doesn't do its job, right? So, I've got my little marks in, that's cool, but I'd want to write in the dip of each of these little marks. So let's see, it's 50, 60, 60, 45. So I'm gonna write 50, my opacity is all the way down. As you can see, I did not plan this at all. Okay, so I have 50, I have 60, I have 60, and I have 45, right? So that's kind of fitting here. Say this is, let's see, Mount Crow, right? So this is the wrong thing. So this is Mount Crow, right? And then this is the Old Man House. There's a house there. So Old Man House, right? So I've got these kind of features on my map. It's helpful if over my cross section I mention where those features are, right? It kind of helps get people orientated. Of course, you should have, when you make your cross section, you need to have where north is. So this is really northeast, and then this is southwest-ish, right? So I know here, kind of in the middle, this is Mount Crow. So my size a little bit. Right, so that's Mount Crow. If you want to see what all this stuff really looks like, nice and neat, please come up to our office. We have quite a few examples of some really spectacular cross sections. I'll see if I can post some of the pictures of them as well. And then over here, that's Mount Old Man House, and that's kind of in the middle there as well. Okay, so this is over here, Old Man House, right? Neatest handwriting that I can do, at least with this weird pen. Okay, and then I want to start to color things in. So I want this to be nice and neat coloring. In this case, I'm going to put down my opacity a little bit. Let's bring my pen size up. Color in the whole thing, right? Color in the topography and to depth, right? Don't just color in right here. That doesn't count, right? I want to see where we think the rocks are. Yes, you can't see them all the way down, but if you just color it like along the lines, that really doesn't look good, right? So what you do is I say, this is my pink area, the rate's neat, and I'm gonna color in this whole section. Right? And you can color it all the way down to depth. Something you are absolutely welcome to do is, say you're in an area and you want to say, you know what, I really don't know what's kind of happening in the depths here, but I do absolutely know that this stuff is on the surface, or maybe I don't know that any of this purple stuff is here. I don't know what's on top of Mount Crow. I wasn't able to get there. So I'll say that the places that I do know for sure, I'll color in with kind of a harder coloring, right? And I'm like for sure that along this contact is this purple, right? So I know I'm pretty sure that all this stuff is down here, right? But I'm not quite as sure over here. So maybe I want to kind of fade my coloring, right? It's still going to be purple. Oh my God. Still going to be purple. Just not quite as purple, right? So this is when you're coloring in colored pencil, but you're not pressing down quite as hard. That is fine that you do that, right? And nice, neat coloring skills. Excuse me. Should look better than a second grader, you know. Although I'll say, for the most part, you guys, all your stuff looked very neat. And then over here, this is green. Give me 1 second. All right, so over here, this is green, and this is an anticline. Now, I don't actually know what's below this, right? I don't know what was folded below there. So, like for me, I might want to actually say, you know, there's a question mark. I don't know how deep this unit is. I don't know the unit thickness. Fade your coloring into nothing and then put a question mark, or just fade it into nothing and leave it as it is. Either way, it's fine with me. Okay, so, but I know for sure here and here. That's fine. Okay, so here I've got a nice green. And I can color that in, right? And I know that I saw that all along the surface there, and I saw along that contact. So this can all be nice green, right? Taking forever to color this stuff in, but you guys know what I mean, right? So I know all here is green for sure, right? Maybe if you saw green on the other side, you can kind of think about what the unit thickness would be. What am I doing? Right? So maybe you saw some green over here, and you know that the green unit was, you know, maybe it was like this, like say this was a bed, it would be like that thick. Sure, you could do that. You might actually be able to take a guess at that with your map, but it's okay if you were unsure what you're doing, right? Right? So, you know, I might want to fade this out here. What is going on? Right, so this is lower opacity down here. Here would be where your coloring kind of lighter, okay? Not my best coloring job, but you guys know what I mean, right? So this is kind of what we're looking for, okay? Now, of course, you want this to be your nicest, your neatest handwriting, but these are kind of all of the basic components that we're looking for. So map out your typography, make sure that you've really measured out your scale, right? Make sure that this is accurate. So this is actually, I did actually measure this. This would be the 200, that would be another 200, that'd be another 200. I've marked kind of the intermediate pieces. I would, if I were you, do the same to depth, right? So that would be about 100 there, another 100, 300 there. You do that. As I said, I will give you a bonus point if you go ahead and make sure you convert things from feet to meters or meter to feet. Either way, have both scales, especially on US topographic maps. Your scale might be easier to do scales in feet. If you have any questions about scales, of course, as always, come ask. There are quite a few good resources online with that if you want to look there as well. When you go through, make sure that you are pulling up, you know, your actual map, right? So what did you see in the topography? How does your data kind of intersect the cross-section lines? your cross sections, right, are conveniently angled so that you do not have to assume that the dip is anything but true dip, right? So here it's true dip. Just go ahead and mark that in. Don't need to do the math for it. Make sure that you put in the little dip marks, right? So they don't need to be that big, just enough so that I can see them. Write in the dip numbers. What also might be useful is that if on your map you have that this would be stop 1, write stop 1. If this is stop 2, write stop 2, right? Those kinds of things. You don't need to put every single dip on your map for these maps, but I do expect kind of enough so that I can see kind of from your map to your cross section what you did. So like I was expecting, since it was your first map that you guys did, or your first cross section that you guys did, to see like maybe 10 dip marks on your cross sections. I probably will be looking for about the same kind of thing with the freeze map. All right. Put in some of those, where are we markers, right? So there's Mount Crow, this is the old man house, right? So I've got where that is, got where that is. Do it a little neater than this, if possible. But those things are helpful for kind of getting everybody oriented with what they're looking at. Also orientations, make sure this is northeast, southwest. Another good thing to put in is that this is my, ooh, huge. So this is my X side and this is my X prime side. That can be something that you put up here. So you can have, this in northeast, X, southwest, X prime, right? So that would be something to have in your cross section. Here we go. If there's an anticline, right in the anticline, if there is a ooh, been talking all day. If there's a thrust fault, like say that this were a thrust, and we know that it's thrusting that way, right? Kind of like what you saw in Newport. Put in the markers that this is a thrust fault, right? And you can extend the contact into the air. I don't know where that line is. Oh, well. Right. So I can extend this contact into the air, kind of like what I did for the anticline, right? And then up here, I might say, this is a thrust fault. And then, like what you guys should do, especially if you need to fix some things on your Newport map, is that right there, you would call like, we saw the Saltville thrust, so I'll do Saltville thrust, write out the full Saltville thrust, right? But label where that thrust fault is. It helps for people to understand what they're actually looking at. And then when you eventually have to go and say, I was looking at this thrust, or, on the map next to this location, they'll be able to see that in your cross section. Anyways, I hope that covers most of the basics of what you need to do. I'll make sure that I try to get a little bit more feedback to you guys individually, but hopefully this is helpful.